Hi, Mr. Kane here. Now we've made something in the lab. Is it an acid or is it an alkali? How do we tell? So you can't just tell by looking at it. A lot of things that we've got in bottles in the chemistry store just look like water. You know, sometimes you can see, oh, it's a bit gloopier than water, or yeah, but it looks like water. We just can't tell. We need to do something else. So here's a little cartoon. Check it out. We can use a special paper as an indicator for acidity or base. Does that mean I can stop using my tongue? Well, you shouldn't be tasting things in the lab. So we've got something else that's called an indicator that will help us decide if it's acid or base. Is this like indicators on your car tell people around you which way you're going to go? Indicators in chemistry tell you if you have an acid or a base, or it's in the middle. It's a neutral. It's between acid or base. So here are the two of the most common ones that you'll meet in a science lab: litmus or universal indicator. So they're going to help tell us whether we've got a solution, if it's acidic or not. You know, it could be basic, it could be acidic, or it could be in the middle and being neutral. They change colour. So depending what indicator you're using, what colour it will go in acid or basic or alkaline solutions. So you have to know which indicator you have and know what the colours mean. So the litmus test. We've got a range of substances here. We're going to put litmus into it. And it's an indicator, once again, changes colour in acid or alkaline or basic solutions. And it actually comes from lichen. You can see on the rock here, you can see this sort of this scaly sort of stuff all round over here. That's litmus. Well, a lichen. Litmus comes from a lichen. And it's red in an acid, so we can see up in this one here, this is the acid side of things. And it's blue when it's alkali or basic. Okay, so litmus really only has two colours: the red for acid, blue for a base or alkali. So litmus paper and solution, examples of indicators. Most commonly we'll have litmus paper. It comes in these little plastic containers, and you just pull out as much tape as you want. So a little thin strip of paper, and you dip it into the solution that you have. So red litmus is red in acid. Blue litmus will turn red if you put it into aqueous. Red litmus just stays red. So you have to be careful. You've got red litmus sticking into something that stays red, probably is acid, but never quite sure. Let's check with some blue. Okay, so this sort of colour. Blue litmus, it stays blue in a base or alkali, and red litmus will turn blue in alkali. So we've just got the red or the blue. You just have to remember which is which and which way it goes. So red or blue, acid or base. So that's the litmus test. The other one you'll probably meet in the science lab is this thing called universal indicator. It's actually made of a variety of different indicators together, and it has a range of colours that it goes. So here's the universal indicator colour chart, and it ranges from a deep red in acid. So over on this side here we've got reds, and then we've got sort of the yellow oranges for weak acids. In the middle we have green for 7 for neutral. Then we've got sort of bluey colours for weak base, and then we go to deep blue or purple for strong base. So acids on this side, they're your reds, yellows to reds. Alkalis on this side, blue to purple. And neutral or green in the middle. That's the universal indicator. It's more useful than the litmus because it has this range of colours and tells you actually how strong the acid is, or how strong the base is. Okay? So the colour shows the strength, as long as you can remember which colours are which. So those colours relate to what's called the pH scale, or the power of hydrogen. How many hydrogen ions there are or aren't in solution how strong something is an acid or not. So 1 to 6 is acidic, and that's like 6.9 even is still acidic. Now they're acids. 7 is neutral, and only 7. Like I said, 6.9 is acidic. 7.1 is basic, alkali, basic. So then your 8s to 14s definitely basic or alkaline. Only 7 is neutral. Anything above 7 is a base. Anything below 7 is an acid. That's the pH scale. And the colours of universal indicator will help you with that. So here's some normal household chemicals and their pH values. Try yourself out. Which is the weakest alkali or base? Look at the numbers. It's got to be bigger than 7, but if it's weakest, it's got to be pretty close to 7. We've got baking soda. It will be a pale blue colour in universal indicator. Which is the strongest alkali? Look for the highest number there. It's our bleach. It would be a dark blue purpley colour. Which is the weakest acid? Which is the acid that's just under 7? Your wine. So that's wine's got, acids have a sour taste. Wine often has a bit of a sour taste to it. Okay. Which is the strongest acid? The one that you probably wouldn't want to drink. We've got vinegar in this case. It'll be a red colour. And the one thing we've got here that's neutral, the only thing that's 7, that's salt. That would be green in universal indicator. Okay. Can we make our own indicators? Of course we can. We can use a variety of things to make indicators. Beetroot's good. Those are black currants. I've used tea bags. Red cabbage. That's my favourite to use in the science lab. We'll make up an experiment where we use red cabbage to make up our own indicator with that. But you need to know which indicator you're using to know what colour it's going to be. So hydrochloric acid in universal indicator is going to be a red colour. Sodium hydroxide, we put that in red cabbage, you get a green colour. So if you're using universal indicator, green will be neutral and safe. But green in red cabbage means sodium hydroxide, which is basic, not safe. Lemon juice in litmus is red. Water in red cabbage, that's purple. So like in universal indicator, purple means a strong base. Water we know is neutral, so a universal indicator would be green. So you need to know what indicator you're using. Okay, sodium bicarbonate in universal indicator, that's your blue. And vinegar in red cabbage, that's red. Okay, that sort of makes the same sort of colour as it would be in universal indicator. But we need to know what indicator we're using and what colours we're looking for. So we tend to keep it simple, and we mostly commonly use universal indicator, which is our range of colours from reds for acids, blues for bases, and green in the middle. As I say to the students of universal indicator, acids are red, bases are blue. Drink too much Coke, your teeth will turn to goo. So here's our pH scale. 1 to 6, anything below 7 is acids, anything above 7 is alkalis or bases, only 7 is neutral. Reds for acids, blues for bases, if we're using universal indicator. If you're using something different, you need to make sure what you know what colours you're expecting from your indicator. So that's how we tell what sort of solution we've got, whether it's acid or base, the pH scale and indicators. I hope that's been helpful.